Hello, hello. Uh, shall we start? Okay. Have you gone through the previous VIs?
Yes, I try something for the mux function, and then non the other operatings everything I tried it today.
Okay, okay. So today I just share you the complete folder of the VIs. You can try your own. Okay.
Okay, sir.
So first, I have a question for you that I previously asked to you. How many input output ports we can connect through this pattern? Maximum number of ports. Please tell me.
Uh, One second, sir. In the pattern, I saw something. The maximum number is last of the pattern, sir.
So the number count is the count.
Count.
I just tell you, it is 28.
Count.
Maximum number of
Count. Right.
28.
Okay. The last one, the pattern, last one.
Yes, yes, yes. As I just go to the patterns over here. So maximum number of input plus output ports is
Yes.
28.
20.
Okay. So today I just take an example of sub VI also with different functions, like I want to convert the temperature into the given temperature that is available to me from Celsius to Fahrenheit and Celsius. So I have
Okay.
just both the options. By using a switch, I just convert these two uh, values or the given value into the temperature. Okay, that
Okay.
is my Celsius or Fahrenheit. So first I just go to uh, pattern to develop a sub VI. So my formula is, let's say, C is equal to F minus
Sir,
32. Hello.
are you sharing your screen? I think
Okay,
so.
okay, okay, okay. So I just share my screen. Wait a minute. Is it visible to you?
Yes, I know.
Okay. In the lab view, there is
Yes,
my
sir.
front panel window, there is my block diagram window. So
Yes.
will you please tell me, which one is the main window?
Uh, Main window is front panel, sir.
Okay.
Yeah, whatever you're doing in the black diamond.
Yes. If you just close this block diagram window, can
Okay,
you
sir.
recover it?
Yes, sir. Control T should be automatic.
Control E or Control T, both will work.
Control T, sir. T
um,
for temperature.
Control T and Control E, both will work. Okay.
Okay, sir.
So in the case of any VI, if you just close the front panel and you are not saving it, so in that case it will that process will lose your program.
Yes.
Okay, so I just
Okay.
recover, or you can recover your block diagram window by pressing Control E or by pressing Control T.
Okay, sir.
So over here, here is my formula. Let's say Celsius is equal to F minus 32 into 9 by 5. It is 9 by 5 or 5 by 9?
5
Maybe it is 5 by 9.
5 by 9.
So I'm just creating a formula for it. So over here, so first, this is my constant, or not constant, it is a control for Fahrenheit. and I just put 32 over here. Then I want to just multiply this value with 5 by 9. This is my 5 and this is my 9. So it will give me, create indicator over here. This is my Celsius. So this is my basic formula for Fahrenheit to Celsius conversion. I'm just take an example of how to convert, or how to use this select function that I previously used in the last lecture. So over here, first I just go with patrons. In this case, only two are required. One is for input, one is for output. So just select it, drag it, select it, drag it. It is up to you. You can change your representation also. Right now it is floating type DBL or DBL. So just save it. I'm just saving it on my desktop. The name is Fahrenheit to Celsius. And you can also edit. It is already, maybe you know how to edit, how to place something inside this block. You can edit. It is just like a paint. And over here we have different functions, like in this case we require temperature symbol. Over here, this is my temperature and the icon is F2C. So just okay, and again save it. And just now my formula is ready for Celsius to Fahrenheit. Let's check it. 100 degree Fahrenheit, it is equal to 37.77. It is okay. So right now I just save it and close it and just open a new VI. Okay. In this new VI, you have to just drag your Celsius to Fahrenheit formula. Okay. So as you know, over here, this is my node. As I already told you, the operating function is also called a node. And in this case, I am just selecting select node. This is my select node. Over here, I got the temperature output, final temperature, that may be in form of Fahrenheit or maybe in form of Celsius. So now I just take a numeric input. Control T. So over here, input temperature, and over here I got the value in Celsius or Fahrenheit. So you just, in the case of Fahrenheit, you want to directly connect it, and in the case of conversion, let's say you just below connect it to false. And this switch over here, this switch will help me what is the temperature, it is in Fahrenheit or it is in Celsius. And before it, you can just connect your sensors. Over here, this in place of this input, you can just put your scaling factor, you can just put your input DAC device symbol or node, through which you can just acquire the voltage, because in the LabVIEW or in any case we just acquire the temperature, current, voltage in terms of voltage only. Okay. And we just convert that voltage in terms of temperature. So right now, let's say over here my input is 100. If I just continuously run it, it will give me 37.77. It is in form of Celsius right now. And when I just run it when I just switch it, it will give me degrees in Fahrenheit. It is up to you how to represent your temperature in degree or degree Celsius
Okay.
or in Fahrenheit. It is up to you. Okay.
Okay.
So this is the example of again a select function and also the modular programming. We also called sub-VI a modular programming because we just drag this function multiple times in our VI. It is up to you. You need
Okay.
not to create in between function, that is
Okay.
your this function. It will replace this function. Okay. So now I just explain you how to acquire multiple signals in a graph or in a chart, or also explain you how to what is the difference between a scope and what is difference between chart and what is difference between a graph. So I just take a new VI, and if you in my PhD Viva, not PhD Viva, in my MTech Viva, I just got a question from the external Viva person that how can you convert this black background into white background. It is possible or not? Hello.
For scope or
This one,
normal.
this background that is inside the waveform chart, that is black, can you
Hmm.
change it to white?
Having
Is
no
it
idea, sir.
possible?
Maybe possible. Maybe possible.
Let's check. Go to the tool palette over here. This is my color, and let's if this is white color, you just change
Hmm.
anything. Okay, inside
Okay.
your, or let's
Background tool.
say it should be different color. It is up to you. And
Hmm.
also there are some patterns available in the LabVIEW also directly. You need not to go to this tool palette. I'm just deleting this, and in the over here, as you see, this is a black background patterns, and in the silver pattern, when you go to graph over here again, this is a white background.
Right
This
back.
is a black background, this is a white background. It is up to you. You just go through tool palette, or you just directly
Go for
drag it
this.
from silver.
Okay.
Okay. So right now I just explain you the how you can plot multiple signals inside a single waveform chart or graph. So first I just go to a while loop, not while loop, I'm just using a for loop because I just want fixed number of samples. So
Okay.
again I just go to the mathematics. Over here I just drag two trigonometric functions. First one is sine 1, and over here this lock function is available. You just lock it, your palette is fixed. You can just drag and drop your functions. You need not to go to every time right click in your block diagram window. Okay, in that case,
Okay.
so you just drag and drop. So right now over here this is my sine function, this is my cos function, let's say, and I just use a divide function for clear waveform. The same input is given to both the functions, and over here this is my scaling factor for the frequency. Let's say initially it is 10, and it will give me sine of x, cos of x according to my value. Let's say I just plot 100 values, and in the array function I have build array function. So you just connect as many as samples to it, and over here just go to the waveform graph, connect it to it, run it. In this case, what happened to it? Will you please explain me what happened to it when I just connect waveform graph over here, and when I just change it to over here? So let's say What is the difference between these two? Is there any difference or not?
It's a different experience.
So over here, this will build a array. Like from here, the value comes, let's say for sine of x comes, from here sine of cos of x comes, and it will build a array over here. In this
Okay.
case, as you see over here, from here
Yeah.
scalar value comes, and it will just join the all the values and plot it, and the value is from 0 to 1. And if you just plot the differently, like sine wave on a different axis and cos wave on a different axis, you just go through this. Okay, and if in this place I just delete it,
But both are same, no, sir. It's the arrays. It's a build array only, right? So both
but
inside
the
the
in this case build array is same, but the placing where you are just place, or where you are just using your build array, it is different, because over here the over here in the case of, because every function have its property. Like when I just connect a chart over here, let's see what happened to it. When I just connect a chart over here, it will give me a function like this. It just build values, means adding values. If you just want to check what inside this, just create a numeric indicator over here to check what are the different values. So I'm just increasing, because in this case only one dimensional array is there. So when I hit on run button, as you see over here, single values are there, and it will plot these values over here. Okay, and over here we have a two-dimensional array. Create indicator, and I just it is a two-dimensional array, as you see. Okay, so this is the main difference between these two, and I'm just deleting this inside one. It is up to you where you want to use it according to your application. So I'm just using this one. So now if you want to just change your frequency, or if you want to just change the frequency of individual function, right now both the functions have same value. Okay, so now I just change it to different one, just connect it, and over here let's say the frequency of this is 5, and control E over here. Now input function is this. So when I again hit on run button, as you see, because in this case the frequency is different for both the signals, and it is up to you. As I already told you, in the case of chart you can edit your symbols. Like over here in this plot, these are my two signals. So let's say this one in the over here plot 0 is showing sine function. You can put sine over here, sine of x. It is up to you. And over here it is cos of x. You can edit. Like in this case, if you want to just change the height, width, you can just change. You just want to change the color, you just change. And right now this is the main function. In the graph, in the case of graph, we have an additional function that is not available in the chart. You just go to the visible, there is a cursor legend. If you want to just check the value over a waveform, let's say I want to check the value of waveform over this place, where is my cursor? Okay, so in that case you just need cursor legend. So over here just go to the right click, just first select the cursor legend. It is not available in the case of chart, so just right click, visible. Over here we have different cursor. So in this case right now there is no cursor, so you just create a free cursor over here. It is up to you. There are three options: free cursor, single cursor, as you see over here, and multi-plot cursor. So right now I'm just using free cursor. So as you see over here a line is drawn, and if you want to just check over here these two, sine wave and cos wave, crossing each other, and I want to know the value over this point, so I just move my horizontal cursor, then I just move my vertical cursor. So this point is my inter
Both the signals
meeting point, or you can say crossing point. Okay, so over here in the cursor value you just check the values. Let's say over here the x value is 23 and y value is 0.3074. okay, so this is how you can check the particular value inside a graph. Okay, and this is all the another functions are nearly same. As you see over here, this is the single function that is available inside the waveform graph only. Okay, so you can just try your own, as many as multiple signals. If you want to just go for more functions, let's say just take more signals inside it and just go through the again same way. Let's say over here I'm just using, in this case, multiple signals. In this case I'm just using 5 signals. So it is up to you how many signals you want to place and where you are joining this signal. Let's say in this case I am just connecting this function to the third place, this function to the fourth place, and this function to the fifth place. You just remember also where you are connecting, because according to this function it will plot. So right now I just hit on run button. As you see over here different functions are there, and some signals are overlapping over each other, and you just again select the function plot, and over here you just again change the color, you just change the width also. So this is how you can work with your waveform graph. It is clear to you?
Yes, sir.
Okay, so just I'm just deleting this. So in our LabVIEW over here there is a alarm system also, like beep signal. You can generate beep also. It is up to you how much frequency you require. Let's say I'm just putting, like in a VI you just want to generate a sound signal. Okay, so you just go with this sound signal, and over here you just put the frequency also, and in this case it is the use system alert or not. It is up to you. So when I hit on run button, let's say I just create a constant for it. Right now it is audible to you?
No.
Okay, maybe it is driven by my system, so that's why I'm recognizing it.
Okay.
Right now?
Yes, sir. The beats on this.
Okay, Right now I just removed my headphone. So this is how you can use this audio signal in your system. So should I go for hardware part today?
Yes, I can.
Okay, so I already told you this one button system. You can go with the two button system. This is similar to one button system. Like as you see over here, this is the message box, and this is when what happened when true is there, and this is what happened when false is there. And according to this, you can control your any devices. Like in our day-to-day life, we got just some pop-up to our mobile phone or some pop-up to our windows, and it will drag to me another site or another location. You can go through this one. When true is there, according to true function, you just create a case structure over here, and in that case structure you just put the link, or you just put your operation code of your application. According to true, it will run the true code, and according to false, it will run the false code. Let's say let's take an example over here. Let's say example is let's say you want LabVIEW classes. I just create constant yes. In the another case, it is up to you. You just mention the message no, and over here I just create my case structure, just connect it to, and in this code over here in this page you can just generate your code, or you just put some value. Let's say in this case I'm just putting a simple constant value. In the false case it will generate 0 value, in the true case it will generate 5 volt for me for output outer world. Just connect it, and over here you just take the indicator. So let's run it. Right now I'm not using any loop, so I just run it. So you want classes, LabVIEW classes, let's say yes, it gives me 5 volt when I just put yes. Okay, and when again I hit on run button, you want LabVIEW classes, no, it will give me 0. It is up to you how to use your LabVIEW symbols or how to use these nodes differently. Right now I am just using a simple constant inside this. You can just put a code also inside this. Like if you want to just go just place the temperature, the input temperature in Fahrenheit, you just put Fahrenheit code inside it. If you want to just take the values from temperature sensor and put these values in Celsius form, you just put the Celsius code. It is up to you which type of application you want to put inside this code. And as many as right now in this case only 2 cases are there in the case of build function. If you just go with another function, that is 3 button system, in this case you just need to connect your one button system with numeric part, because in this case we have 3 cases, and in the case of boolean we have only 2 cases allowed. Okay, so in that case 3 button case, you just connect your 3 button, like select output to your this one, and first you have to convert this one into numeric part. Like 1 minute, I just connect it to this one. As you see right now it is 0 1 type, then you just add one case after it, and right now 3 cases are available, and according to this you can create your own VI according to 3 button system. In this case only 2 buttons are there, in this case 3 buttons are there, and in single button only 1 button is there. Okay, and in my hardware VI I just go with simple error handling codes. You just after 1 minute, I just explain you one by one. Uh, do you have any hardware device with you right now?
No, sir.
Okay, so I just uh, bring one hardware, that is Arduino board. 1 minute. Hello.
Yeah, yeah.
So some basics are still left in the future classes. We just go through that. Right now I'm just going through the Arduino board. I'm just showing you the Arduino board. 1 minute. Is it visible to you?
Yes, sir.
Okay. Have you gone through it already?
Yes, sir. I remember that I never use it, but my farmer guy is using this one for
Okay.
the audio jacket.
Okay. In the next lecture, I just bring a LabVIEW device, that is NI USB 6009. Okay. Uh, 6009 I have in my college. I just bring that,
Okay.
and then I just bring my Rio. This is a FPGA board basically. Okay, and another one deck card is my deck. This is a educational deck card. Okay, on these deck cards, you already know that there are digital ports, there are analog ports. Have you worked with them?
No, sir. No. Software side I never worked before.
Okay. So right now, today, I will tell you how to interface this Arduino code using LabVIEW, or how to code this Arduino board using LabVIEW. So first hardware part we go through. So I just first tell you how to uh, interface its library inside your LabVIEW. So you need to just go to search box, type VIPM, VI package manager.
VIPM. Okay, sir.
Okay, basically this VIPM, using this VIPM, we can interface third party devices that are not from NI.
Okay, sir.
Okay, and in my LabVIEW there is a NIPM also, NI package manager.
NIPM. Okay.
Okay, so using NIPM you can install different libraries that are available, or that are available by NI. Okay, and by VIPM you can interface or integrate your devices, or integrate any library inside your LabVIEW that are through the third party, like Arduino board that is not a part of NI. So in this case I'm just explaining you how to go through VIPM. So it will take some time. First time it will download all the libraries. Like if you want to work with biomedical library, you just go to the VIPM. The biomedical library is available, and in, as you told me, you want to interface different hardware devices to
Yes,
your
sir.
LabVIEW. If these hardware devices are from LabVIEW, in that case you just go to the NIPM. Otherwise you just need VIPM.
VIPM or NIPM for
Yes,
configuration. Okay.
yes.
I have NIPM.
Yes, in the first time when you install LabVIEW, the both VIPM and NIPM are available in your system. It will ask you, you want to just install it or not. So as you see over here, this is my NIPM. In this case, I have total 216 installed libraries. Like as you see over here, this is a circuit suite. Basically, if you want to just simulate any circuit like RLC, like any filter, you just go to circuit design suite. Basically, it is a multi-sim that is available inside the LabVIEW. If you want to just go with hardware devices, we just go with this DAC Express. If you want to just go with graphical G web development, G stands for your graphical language. In the case of LabVIEW, if you want to go with web development, you just need this web development software, and there are different uh, libraries available in this. So over here, this is my library, that is VIPM. Using this,
Okay.
you can interface or integrate any third-party library inside LabVIEW. So right now, when you just go through it, it is downloading libraries right now. Every time when you open it, it downloads different libraries that are available in the market. So as you see over here, these are the different libraries that are available over here, and you may also check your device, like if you want to that hardware device library also may be available over here, the hardware device library. In this case, I'm just going to Arduino. You just put Arduino in the search box. As you see over here, these are the 4 types of library available. Using these 4 types, you can program your Arduino. Right now, I'm just explaining you using Linux. This is my Linux. Digiland Linux. Using this library, you can control Arduino, Raspberry Pi, Beacon Bone, and one legend controller is also there in the library. You just check it. First, you have to just, like I am explaining you how to install it, just select it. Right now this library is not installed in my system. You just select your version. Right now in my laptop there is LabVIEW 2021 version is there. Okay, then you have to just select the uh, library over here. I'm just selecting this library. You just click on install. When you just click on install, it will drag to your pop-up box. It will ask me already student version is there. If you want to just this version, you just need to uninstall that version. Okay, so it automatically uninstall that version. So right now I'm just closing it. In this case, it will automatically open your LabVIEW software when it is just installing. So in my system already this Linux library is there. So over here the name is Maker Hub. It is from Maker Hub. So I just close it. So this is my main library, that is for Arduino. In every case, when you just go through hardware part, you just need to configure your port that is connected to your PC. In every case, you just in maximum cases, you just going through USB port. Okay, as you see over here, I'm just showing you. As you see in this case,
Yes.
I am just using this cable and
Yeah. USB.
USB. It is
Yeah.
connected to my system, and when I just connect it to my system, it will create a port to my system, and you just check this port through the device manager. You just go to device manager,
Yeah. Device model.
just open it, and it will show you which device is connected to your system through which port. So in the ports, I just drag it USB serial CH340COM5. It is connected to COM5. Okay, so in the case of LabVIEW, when you just want to program your Arduino through LabVIEW library, you just go to the tools. Over here there is a maker hub. Go to the Linux, just go to the Linux firmware wizard. When you just click on this, in every time when you just connect your Arduino with your system, it will require this file. Once it require your file, because Arduino, in the case of Arduino, it is programmed using C like language, text language, but right now we just program it through graphical language, so it need a interfacing file. You just select your Arduino. Over here these are the different device families like Arduino, Dizient, PGR, C and SparkFun. Right now my device is Arduino, and over here you just need to select your board. This board is Arduino Uno. Okay, and over here you just need to select how you upload your code. There are three options: USB, Wi-Fi and Bluetooth. Okay, so right now it is USB, so just press next. Over here it need your COM port. As you see over here, I just select my COM port. Next, over here we have a pre-built firmware wizard. Right now I'm not using it. I'm just interfacing. I'm just uploading the basic code inside it. It will take some time in uploading, and when it is uploading the code to the Arduino, its TX and RX transmitter and receiver pin will blink. So once it is done, just finish it. Right now I just go to the code. First I just open my port, close it. In between I just use my first, in this case I'm just using generating a signal, digital signal. I want to just generate a digital signal. So in this library, just go to the peripheral. Over here we have digital, analog, PWM signals, I2C protocol, SPI, different protocols are there. I'm just selecting digital pin. So right now I want to just generate. So over here there is a read option, there is a write option. So I just write because I want to just generate. You just connect your Linux resource input to output of another node, error in to error out in every case. Okay, so first it is connected, then you just go to the dialog and user interface. Over here you just need to select simple error handler. If some error is there, it will resolve its own. Okay, so now you have to just select the serial port, create a constant for it, and my serial port is COM5. You just need to select over here with which port your Arduino is connected to your system. Then over here you just set your baud rate also. The baud rate of node Arduino Uno is 9600. In this case it is different for every device. Okay, so now I want to just generate continuously, so I just create a while loop over this write function only. As you see, shift registers are automatically created over here. Then create a control for this, and right now the pin number is needed, because with which pin you want to generate a signal. On my Arduino, this one, there are 13 pins are available on this side. Okay, so right now you have to just select the pin number, so create constant for it. Right now I just put 13 over here, and this one is the signal. Control Z. I want to just connect a switch to it. So over here switch is connected. And if you want to just check the connections, put Control H. As you see, first one is line next resource, then digital output channel, output value, which means you want to generate true signal, you want to generate false signal, or 0 1. Okay, in this case. So I'm just closing it, and when it is done, you just need to run it. When it is running, right now it is running, you just need to,
Yes, the light.
as you see, onboard LED. I have a onboard LED. There are 4 LEDs right now, TX, RX, continuously running, and this one LED is right now on. When I just press it, off. Right now it is off condition. It is visible to you?
Yes. Yes, visible.
And if you want just another LED, give me a minute. I just connect another physical LED to it. 1 minute. Right now it is visible to you?
Yes,
1 minute. It is visible to you?
Yes, visible.
I just connect positive pin of my LED to the 13 number pin, because I'm just generating a signal through 13 number LED, and ground is connected to negative pin. And when I hit on run button, as you see, LEDs go high, off, high, off. If you want to just change another pin, it is up to you. Right now I'm just not interfacing my Arduino with my LabVIEW. Right now I'm just going not uploading this code, because I already did that. In that case, if you want to just change any pin, you just go to over here. Let's say I'm just using pin number 10, and in this case I'm just change this pin to the pin number 10. Positive is connected to the pin number 10, and ground is connected to the negative pin. Right now I'm just not connecting any resistance, because in the hardware part you just need a resistance, because this Arduino will provide you 5 volt and it will burn your LED. Right now I'm just connecting it without resistance. Okay, so again, right now I just change the pin number, as you see over here. So when I again hit on run button, it is not generating signal through 13 number pin. Right now it generates signal through pin number 10. So when I hit on run button, it will generate a signal. Okay, so this is how you can generate signals using Arduino board. It is very simple. But in the case of Arduino, if you just go through the Arduino code, I just show you. There is a Arduino IDE. I just stop it. There is a Arduino IDE. Using this, you can control your Arduino board without using LabVIEW. So it will, yes, it will take some time. 1 minute. There are so many applications running, and right now there is a on every hardware, like when you are dealing with any microcontroller, there is first program to blink a LED. Okay, so in this case, if you want to blink this LED, you just need to change the code. Let's say I'm just using a shift registers over here. Just make it initially, let's say, true, and this value that is controlled by me, it is just automatically generated. Let's check. So I just use a negate function inside this, and I just connect to this one. In the previous case, I am generating the signal. Right now,
Okay.
initially true is there. When it goes to over here, true function is there. Okay. Then it will
Okay.
negate it. False is there. In the next
False.
iteration, it will
False.
automatically false it. And
False.
I just
How?
put a delay over here. Otherwise, it is not possible to us to visible it because it is very fast. So I just put let's say 1 second delay inside it. So right now when I again run it, on off, on off, on off. This is how you can generate or how you can use your logics inside LabVIEW for generating hardware signals. Right now it is generating a square wave also, because it is generating true false true false true false, and it is up to you how much time. And if you want to just change the duration also, you just go with PWM pin. Right now over here it is not possible to you to change the duration of this high low, because in this case the high low duration is fixed. Right now it is 1 second, you just make it 2 second, 3 second, 4 second, it is up to you. But you just not change the duration like 2 second on, 4 second off. For that purpose you just go to the case structure, and over here you just put your timings. It is clear to you?
Okay. Yes, clear.
You just make it, and you just bring this Arduino from your colleague and just try your own. Okay.
Actually, we are using the same method, not RDO. We are using MATLAB IDE.
Okay.
MATLAB. Yeah.
You are using MATLAB.
Yes.
Okay. I just I already created a course on the that part, because you are using maybe Simulink.
Yeah.
In the MATLAB Simulink, you are using that part, and you just drag and drop the functions, and in that case you just assign the pin numbers. Okay, so it is the same way, but in the case of Arduino it is very easy. But in the case of LabVIEW it is very easy to interface different devices. Okay, so this is how you can generate a single signal. If you want to just generate multiple signals, in that case you just need to drag and drop multiple write signals over here, like just drag, copy it, connect it, connect error to error. Over here you just need to set the value of pin. Let's say I'm just want to generate through pin number 13 in this case, and I just need this signal. Right now I have two LEDs, one onboard LED that is connected to pin number 13, and one is pin number 10. When I just run it, both the LEDs will blink alternatively. So when I just hit on run button, it will show you. It will take some time when TXRX running, as you see.
Yes.
Onboard LED and the LED connected to the system, both are running alternatively. Okay, so you can generate as many as signals, right? It is the limitation of the hardware. If you want to grab the multiple signals, right now I'm just generating the signal. If you want to just read the signal, the process is same. In that case you just stop the code, delete this one, because I'm just hello.
Yes.
In that case you just, in place of write, you just need read. Yes, just go to the maker hub, over here in the peripherals digital read signal. Just connect it again. And over here, this is the value in the form of true or false. And over here, this is the digital pin with which you want to
read the data.
yes. Right now, let's say it is 13 number pin. In that case, I need a jumper wire. 1 minute. Hello.
Yeah, yes, sir.
Is it visible to you? Right now, I just take a single wire. I just connect its one end to the 5 volt that is available on board Arduino.
Okay.
I just connect this pin to the 13 number pin.
Ground to 13.
Not ground to 13.
5
5
volt
volt to 13.
It's a pull up.
Okay.
Yeah.
So when you just run it, the LED goes high, as you see. Okay. And when you just remove it, it goes low.
Yeah, it's okay. It's a surprise. Okay.
It is up to you. As you see, right now it is not connected. The port is, when I just connect it to ground, it will off. You just need not on the hardware part, you aware more than me because you are dealing daily in the daily life. You just when you just assign a port on hardware, you just need to connect to any value, maybe positive value or VCC, or you just make it ground, like as you told me, pull up position or pull down position. Pull
down.
Okay, it is up to you, but in every hardware there is some configuration available inside any hardware, that is, it may be pull up or it may be pull down. According to that it will work. Okay, so this is how you can read a digital signal, and this configuration that is shown on the block diagram window, it is same for NI deck also. Yes. When I just right now I just minimize it. 1 minute. In the case of NI deck cards, in the measurement input output, this is my NI deck max. Okay, you just locate. In this case, I just, in every case, when you just deal with NI deck cards, you just create a channel. First, there is a little difference between Arduino programming and NI DEX programming. You just drag your create channel block, then over here we have read and write options. Before these, you just need to start the task, and the pattern is fixed when you are dealing with deck cards of NI. Just connect this, and over here you will need to select your type with which value you are dealing with, like analog input, analog output. In the analog input, it is a current, it is a voltage, it is a force, because NI provides different hardware devices for every type. Like if you are dealing with force, there is a different deck card. If you are dealing with a resistance, current and voltage, there is a same deck card. But if you want to work with torque, there is a different deck card available in the market. They are dedicated to specific value or specific type. Okay, like over here In the on the third party hardware, like we have Arduino board, we have different hardware part available in the market, like Node MCU. Have you heard about Node MCU? ESP32.
Node ESP, DSP32, yes, sir.
Okay, so on these hardware devices, there is no analog output port, but in every NI DAC card, there is two. There are two analog output ports. Okay, using that analog output port, in the case of Arduino, you just need a PWM signal to generate, let's say 3 volt, let's say 5 volt, 3.5 volt. Using the variation of your pulse, you can generate analog signal. But in the case of NI DAC card, there are dedicated analog output port. Only two ports are available. Next time, in the next lecture, I just show you the DAC device also. But over here, when you just go with the DAC devices, you just first select the channel, then start the task. In between, you just place read or write option. After this, you just stop the task, and over here you just put your while. In the next lecture, we will discuss with this DAC card also. The configuration is nearly same. The cost factor is different. The cost of NI DAC card is around 10,000, and the cost of this Arduino board is around only 1500. Okay, so you can generate these signals using this one, and in the next lecture we will discuss about this in detail. So right now I just explain you different components of LabVIEW. In the string functions, if you want to just convert any value, like in the case of hardware interfacing, let's say we have a input string from the software part, and you want to just convert it to a voltage signal. If you want to just convert it to a particular value, you just go to string to number conversion. Over here we have available string to number conversion, and there are different. Over here there is a decimal string to number conversion, and over here we have number to decimal string conversion. You just use these functions inside your hardware part. One by one we will discuss in our lectures. So for today, maybe this one is okay.
Yeah, okay.
You just first try previous exercise, and if you have some doubts, then ask me. Then I just go to the more complicated functions that are available in LabVIEW. Like in next lecture, I just explain you how to use this disable diagram structure, conditional disable. There is a most important structure in the LabVIEW, that is event structure. Okay, and there are some local variable, global variable. Like if you want to send your data from one VI to another VI in a same project, then you just go for local variable. If you want to just send your data from one place to another place, or one project to another project, then you go for global VI, that is global variable, that is available over here. We just discuss about these differences. So right now in the structures, we just deal with this one. For loop, while loop already covered, case structure already covered, flat sequence, for loop, Muller node, math script. These functions are covered. In the next lecture, we will discuss event structure and these functions. Okay, and also